Section 2.6 is on rational functions. So the definition of a rational function is that it's a quotient of polynomial functions. So we would say if f of x is a rational function, it would be equal to p of x over q of x as long as q of x does not equal 0. Okay, because that's in the denominator. We couldn't get a 0 here in the denominator. You have to be careful with your domain because it is a fraction. You don't ever want your domain values to make your polynomial undefined. So we say the domain is the set of all the real numbers, but excluding the ones that would make your denominator equal 0. Okay, so we've looked at finding domain before in a previous section, but these are just specifically for the rational functions. If you wanted to find the domain, we would want to restrict anything that would make the denominator equal to 0. So I would set x minus 9 equal to 0, and that would give me x equals 9. So that means 9 plugged in would give me an undefined function. So I do not want x to equal 9. Now we can write the domain in set notation, which would be the set of all x such that x does not equal 9, or in interval notation, which would be that x could be anything from negative infinity to 9, parenthesis, union, to u, and then 9 to positive infinity. So it would just skip over the 9. Okay, pay attention to the directions on the homework to see how they want you to write that. So I would do the same thing on number 2. Take x squared minus 4. We do not want that to equal 0. We can factor this as x plus 2 times x minus 2. So that would give me x is equal to negative 2, or x is equal to positive 2. Those two values would make my function undefined. So if I wanted to write this in set notation, it would be the set of all x such that x does not equal negative 2 and x does not equal positive 2. Or interval notation would be from negative infinity to negative 2, union negative 2 to positive 2, union 2 to positive infinity. So that would just be any real number except negative 2 or positive 2. Okay, on number 3, again we're going to do the same thing. Take x squared plus 16. We do not want that to equal 0. Well, that's not going to factor, and if I tried to solve it by the square root property, I would get x squared equals negative 16. When I take the square root, it would be plus or minus 4i. Okay, and I is not a real number. So with our domain, we're only focusing on real numbers. You know, what real numbers would make this be undefined? Because there is not a real number that would make your polynomial function or your rational function undefined, we say that our domain is all real numbers, negative infinity to positive infinity.